Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 2, solving for unknown angles using, and I say using equations. Okay, no more arithmetic. Equations. Classwork, opening exercise. Two lines meet at a point. So there's one line. And here's another line. Those are the two lines that meet at a point. In a complete sentence, describe the relevant angle relationships in the diagram. And here it is. There is the answer to that question, or that statement. The two intersecting lines form two pairs of vertical angles. So this is a vertical angle to that, and this is a vertical angle to this. S equals 25 degrees since vertical angles are congruent, and angle R is equal to angle T. Angles S and R are angles on a line that add up to 180 degrees. So we would say S plus R equals 180 degrees. But we already know S is 25, so we substitute in our given information. 25 degrees plus R equals 180 degrees. Subtract 25 degrees from both sides and we will find the value of R. 180 minus 25 is 155 degrees. So R is 155 degrees. T is 155 degrees because R equals T. And S equals 25 degrees because they're vertical lines as well. So we have 155 for R, 25 degrees for S, and 155 degrees for T. Okay, example 1. Two lines meet at a point. Here's a line. Here's a line. That is also an endpoint of a ray. So at that point, there is a ray coming out right here. That is a ray. Okay, so we have the red line, we have the green line intersecting, and from that vertex, we have a ray coming out of it. In a complete sentence, describe the relevant angle relationships in the diagram. Set up and solve an equation to find the value of P and R. Okay, the angle R is vertically opposite from and equal to the sum of the angles with measurements 28 and 16. So if you look here between the R angle between the red and the green line is vertical to between the red and the green line over here. Vertical angles are congruent, and so what this is saying is the measurement of 28 and 16 adds up to 44 degrees. So therefore, these two angles add up to 44, then R is 44 degrees. And if we used an equation, we would say 28 degrees plus 16 degrees is equal to R degrees. So R is equal to 28 plus 16, which is 44 degrees. Then it says angle R and P are angles on a line that add up to 180. So R and P are angles on this line. They add up to 180. So angle R plus angle P equals 180 degrees. Well, we've already found R. That was 44 degrees plus P degrees equals 180 degrees. Subtract 44 degrees to get P by itself. 44 minus 44 is 0, and I get P equals 180 minus 44 is 136 degrees. So P is 136 degrees. We found the value for P and R. P is 136, R is 44. Exercise 1. Now it's your turn. Pause the video, try this problem, come back, see how you did. Three lines meet at a point. In a complete sentence, describe the relevant angle relationship in the diagram. Okay, so the sentence says the two angles and the 2A degree angles and the angle that's 144 degrees are angles on a line. So what they're saying is we have a straight line right here formed by this angle and this angle and this angle. Three angles add up to 180 degrees. So I would say A degrees plus 144 degrees plus A degrees equals 180 degrees. Combine my like terms. 2A degrees plus 144 degrees equals 180 degrees. Subtract 144. We're trying to get this A by itself. Subtract 144. And 144 minus, that's not a 4, that's a 1. 144 minus 144 is 0, leaving 2A degrees equal to 180 minus 144 is 36 degrees. 2 A's is 36, so if I divide by 2, then I get A to equal 18 degrees. Find the value of A, it is 18. 18 plus 144 plus 18 equals 360 degrees. Example 2. 3 lines meet at a point. Here's a line. Here is a line. Here is a third line. I can draw that a little bit straighter. Oh, that was even worse. Okay. Okay. So there's our 3 lines, red, green, and blue. Describe the relevant angle relationships in the diagram. Okay, so if we let y be the angle that is vertically opposite and equal to the 19-degree measurement, in other words, here's angle 19 formed by the red and blue lines, and here's the other side. Those are vertical angles. And we're going to call this y. Okay, so it says let y be the angle vertically opposite, equal in measure to this one. The angles Z and Y are complementary and add up to 90. So if this is 90 degrees right here because of this square, the blue line here and the green line here are perpendicular, which means they form 90-degree angles. So all 4 of these angles are 90. And when I say all 4, I'm talking about ignoring the red line. So the green to the blue is 90 degrees, and that's made by these 2 angles, Z and Y. So the first thing I would say is y degrees equals 19 degrees because vertical angles are congruent. And then I would say c degrees plus y degrees, that's this angle here and this angle here, is equal to 90. They are complementary angles. And I know y is 19, so I'm going to substitute that in. And I'm going to subtract 19 degrees from both sides to get C by itself. And these cancel, and I get C equals 90 minus 19, which is 71 degrees. Exercise 2. Now it's your turn. 3 lines meet at a point. Angle AOF is 144 degrees. In a complete sentence, describe the relevant angle relationships in the diagram. Set up and solve the equation to determine the value of C. C is this angle right here, angle EOC. Pause the video, see if you can do it, come back and see how you did. So now we have angle EOB. Where is angle EOB? I will use my green marker, angle E, down to the vertex O. And over to B is this angle here. It's formed by adjacent angles EOC and COB. So it's this angle here and this angle here. These 2 angles form that whole thing. It is vertical to the 144 degree angle. Okay? So I'm going to draw this, then I'm going to erase it. But if I drew this line straight through like that, and that line straight through like that, now you'll see that this is congruent to that. That's what we're talking about here. So, the measurement of angle EOB is C plus 90 degrees. That's what this means. So C degrees plus 90 degrees equals the vertical angle 144 because they're congruent. So here's my equation. Subtract 90 degrees from both sides and we will have the value of C. So that will be 54 degrees. Okay, example 3. Two lines meet at a point. Here is one line. Here is the other line. And then we have a blue ray coming off here. Okay, two lines meet at a point that is also the endpoint of a ray. The ray is perpendicular to 1. So the green line here and the blue ray are perpendicular. So this is 90 degrees right here. In a complete sentence, describe the relevant angle relationship in the diagram, set up and solve an equation to find the value of p. Okay, so a complete sentence would be the measurement of the angle formed by the adjacent angle of 26 degrees and 90 degrees is the sum of the adjacent angle t. So I could call this like y or something like that. This angle is vertically opposite and equal in measurement to angle t. So if I called that whole thing y, then I'd say y degrees equals t degrees because vertical angles are congruent. But y is made up of 26 plus 90. So I'm going to say 26 degrees plus 90 degrees, which is my y, equals t degrees. 26 plus 90 is 116 degrees, so that is my p, 116 degrees. Exercise 3. Now it's your turn. Pause the video, see if you can do this on your own. Come back, see how you did. One possible response, because there's more than one. Let x degrees be the angle vertically opposite and equal in measurement to the 46. Okay, so if I want to point out how 46 was made, it would be this line here, and the other side of 46 is down here, so it's this. Actually, yeah, let me use the same color. It's this here. So there is my x that I'm looking for, and this is the 46 degree angle. And so therefore this is 46 degrees. Okay. So if I called that x, let's not put 46 in there yet, but it is 46. Okay. Put that back there. If I called this x, v, if you can see this whole thing, v is this angle here plus this green angle down here. So it's the sum of these two. So one possible response would be let x be the angle vertically opposite and equal in measure to the 46 degree angle. The angles x and v are adjacent, and the angle they form together is equal to the sum of their measures. Okay, so what they're saying is v equals this piece, which is 90 degrees, and this, which is 90 degrees plus x degrees, but keep in mind, we know that x is 46 degrees. Okay, so v equals 90 degrees plus 46 degrees, so v equals 100 and v equals 136 degrees. Set up and solve an equation to find the value of v. So that is done. There is our answer. V equals 136 degrees. Next example. Example 4. Three lines meet at a point. There's that line. There's this line. And there's this line. Those are the three lines that meet at a point. In a complete sentence, describe the relevant angle relationships in the diagram. Set up and solve an equation to find the value of x. We're looking for this guy right here. Is your answer reasonable? And explain how you know. So the angle x is vertically opposite to the angle formed by the right angle that contains and shares a common side with an 8-degree angle. So this x is from green to blue right here. And we want this down here as well. But we know that from blue to green plus green to red, this little piece here is a total of 90 degrees. Okay? So I know that x degrees is going to equal a 90-degree angle minus this little smidgen here, which is 8 degrees. So this blue and red line are perpendicular, so that's 90. So if I take away this 8 degrees, that's my x. So x equals 90 minus 8 degrees, so x equals 82 degrees. Okay, and is that answer reasonable? Yes, because the angle marked by x is close to appearing as a right angle. It's very close to being a right angle is what they mean, and it's only 8 degrees off, so that does make sense. That is a reasonable answer. Exercise 4, now it's your turn. Pause the video, see how you do, come back, and we'll take a look. Two lines meet at a point that is also the end point of two rays. Okay, so where are these two lines? Just pick a line and draw a straight line through. That is a straight line. That is not one of the rays. This is a straight line. That is not one of the rays. We'll do the rays in blue. Here is a ray, and here is a ray. Let's do the lines in red, both of them. Okay, so there's my two lines, red, and my two blue rays. These are not straight. There's a bend here, so those are not a straight line. That is not 180 degrees. Okay, so two lines meet at a point. It's also the endpoint of two rays. In a complete sentence, describe the relevant angle relationship in the diagram. Set up and solve. So here is my sentence. So just minimize that and move it out of the way. There we go. Okay, so angle AOC. And where is that? Angle AOC. I'll mark that with an arc. Is vertically opposite from the angle formed by adjacent angle 90 and 25. So there we have it. Those are vertical angles because they're formed by those two red lines. Okay, vertical angles right here and right here. And we know they're congruent. So I would say 2x plus 3x equals 90 degrees plus 25 degrees. Okay, so I'm taking this angle plus this angle. It's equal to this angle plus this angle. So 2x plus 3x is 5x. 90 plus 25 is 115 degrees. Divide both sides by 5, and I get my x. Okay, so x is 23. I'm not going to put a degree symbol because it says 2x degrees, and x is 23, and the degree symbol is already there. So 23 times 2 is 46 degrees, and 23 times 3 is 69 degrees. 23, 46, 69, yes. Okay, 90 plus 25 is 115, 69, and 46 is 115 as well. All right, exercise 5. In a complete sentence, describe the relevant angle relationships in the diagram. Set up and solve an equation to find the value of x. Find the measures of angle AOB and angle BOC. Okay, so here's our sentence. Angle AOB and angle BOC are complementary. So what they're saying is angle AOB, try that again. Angle AOB and angle BOC are adjacent angles that add up to 90 degrees, and therefore we say they are complementary, and their sum is 90. Set up and solve an equation to find the value for x. So I would say angle AOB plus angle BOC equals 90 degrees. Angle AOB is 5x plus angle BOC is 2x plus 20. And they equal 90 degrees. Combine like terms. 7x plus 20 equals 90 degrees. And when I subtract 20 degrees, I get 7x equals 70 degrees. Divide by 7, divide by 7, and x equals 10. So 5 times 10 is 50. And 2 times 10 plus 20 is 20 plus 20, which is 40 degrees. And 50 degrees plus 40 degrees does in fact add up to 90 degrees. Okay, B. Katrina was solving the problem and wrote the equation 7x plus 20 equals 90. And she wrote this as 7x plus 20 equals 70 plus 20. Why did she write the equation this way? And how did this help her find the value of x? Okay, so what she did was she grouped the quantity on the right-hand side of the equation similarly, so that of the left-hand side, okay, similarly to that of the left-hand side. This way, it is clear that the quantity 7x on the left-hand side must be equal to the quantity 70 on the right-hand side. Okay, so she broke up that 90 to be 70 plus 20. Okay. All right. So in other words, she saw 90. 90 is the same as 70 plus 20. And since there's a plus 20 here, she subtracted 20 from 90 and called the 90 70 plus 20. So when the 20s cancel, you can simply see that x is 10. Okay. And that is the end of lesson 2. Go to your problem set. And oh, by the way, smash the like.